Okay, a lot to learn today. It's 1.4.1, and the first thing is I need you to remember domain. Domain is important for this lesson. So if I, for instance, gave you this function, f of x is 2x minus 1 underneath the square root, root of 2x minus 1. What is this domain? Remember how you take the square roots and you set them something, and you solve them, and then you'll know that, oh, x has to be like bigger than 1/3 or something. Solve this one. Find out what its domain is. I'll pause for a second while you remind yourself how to do that. All right, here we go. So you should have said that 2x minus 1 greater than or equal to 0. Raise your hand if you started that way. Okay, good. Then you're going to add 1 to both. 2x is greater than or equal to 1. X is greater than or equal to 1/2. Did I do that right? Okay. So now, if I were to put that on a number line, do you get that that would be 1/2? Could be that, and it must be bigger than that. Do you remember how to do a number line for it? Because you're going to need that today. Okay, so why do we need that today? Well, typical problem today asks us to find the domain of f of x, and then it'll give us a different problem, g of x, and it'll ask us to find that, and then it'll ask us to combine them. So let's say g of x is equal to 1 over x. Well, that's a pretty simple example of one that you can crash with only one number. What could you crash this with? 0. So basically, you just set the denominator cannot equal 0. X not equal to 0, and then you solve it, but it's already solved. X cannot be 0. Okay? So then what's the domain of this? Well, on a picture, it would look like this. Here's 0, and it can't be 0, and it can be everything else. Does that make sense to you? Now, this is a little more esoteric, but imagine for a moment you are the product of your mom's side of the family and your dad's side of the family. Okay? For me, my mom's side of the family had a weakness in like a little bit of, what's it called again? Lupus, and somebody in her side of the family had lupus, and somebody on her side of the family had alopecia, and those are both autoimmune type of disorders. Okay, both can be lived with, but they were, kind of things that people had to deal with in that side of the family. Other side of the family, my dad's side of the family, and that side of the family was pretty much cancer, but thankfully not until late in life, which is a big difference. Because some people get it early in life and some people get it late in life. I'd much rather have it late in life, because they say if you live long enough, most guys, for instance, are going to get prostate cancer if you live long enough. It's just something we have in our society nowadays that almost everybody gets it. If you live to be like 90 or 100, you can probably have it. So anyway, cancer, if it's really late in life, is probably not as big of a deal to worry about. Like heart attacks early in life, not a good thing to have in your family. I got a friend that's that way. His dad died at age 50 of a heart attack, and so he's nervous for himself because those kind of things go down to the children, right? All right. So if you were to look at your family history, and you look at your mom's side and you look at your dad's side, you probably have some weaknesses on both sides, neither of which might affect you, or maybe both will affect you. You don't know. How does that have anything to do with this? Because this is like the mother function. Or maybe we should make this one the mother function, because then this one's an f function, so it can be the father function. And both of them have weaknesses, and they pass them down to the children. So if we do anything with these two functions, like f plus g, adding the two functions together, that makes the child function made up of the two parents, then the domain of that child function is going to be this domain along with this domain, overlapping each other like this. And where does the one domain overlap with the other domain? Well, do you get that in this little zone right here, both functions would be completely happy with any number bigger than 0? Oh, did I put the 1/2 on? You're right. I put the 0 on the wrong side. Thank you. I was thinking that was a negative 1/2. It is a positive 1/2. You're right. I should move this over. There. Now my 0's in the right spot, because 0 on this would be like right here, right? Okay, thank you for catching that, because that's important. Do you get that up to here, both functions are happy from 1/2 over? 1/2 to infinity. Both functions will be happy. So the product of these two, or sometimes it's a product, but the combination of these two functions, as a mother and a father function, so to speak, has a child function, the resulting function, has that domain. That's where it'll work forever, but there's more. No, wait. In this problem, I don't think there is any more. Is there any other areas where they overlap? No, just that one area where they overlap. Sometimes you'll have like another area that overlaps, like down here it also overlaps, but this one doesn't work over here. Okay, so it doesn't work down there. And it doesn't work in between in here with the 0 either, right? Or between 0 and 1/2 doesn't work in there either because it doesn't work here. Okay, so it only works from 1/2 to infinity. So how would I write the domain of the resulting function? You'd say from 1/2 to infinity, where it can be 1/2. Notice it's a filled in circle here, and that half works here too. Bracket. To infinity, you can never touch infinity. So there we go. That's the combination of two functions and their domains combined. It's like two parents making a child, and the child's weaknesses passed down from the two parents. All right. So here is a typical question then. I just ran through the hardest part of it all. So now let's see if you can handle, I can give you two functions. F of x is 1 over x plus 4, and g of x is, let's say, 1 over, no, let's make this one a square root. Square root of x plus 3. I'd like you to figure out the domain of f. We're going to call that d sub f, the domain of f. I want you to figure out the domain of g. Then I'd want you to figure out what is f of x times g of x and the resulting domain. It is just as easy as you might think to multiply the two functions. You just multiply them. This is one function. This is the other. And remember, this one's over 1. If you want to make them be fractions, if they're both fractions, fractions play nice with other fractions. So I'd recommend that little divided by 1 here so that when you add them, when you multiply them, the fractions will multiply nicely. All right, I'll pause for a second while you give it a shot. Don't expect you to be perfect yet. I just showed you one example. If you can learn it from that, you're probably in the wrong class because it's probably too easy for you. But maybe you can get it. If you get it, maybe I'll give myself credit. I might have explained it well. Yes?
So did we just add them?
No, you are. The reason I know it's multiply is on the board it says a little dot right there that says multiply. That last one, we never actually combined the two functions. All we did was find the domain of the combined function. So in this one, I'm asking you to multiply the functions and then find the domain of that combined function, which again is the two parent weaknesses overlapped with each other. Okay, give you a second to think. If you're already done, awesome. Just make sure your answer's in interval notation. So the answer might be square root of 2x over x, and the domain is from negative to infinity to 0, something like that. All right, here we go. So let's see if you did it right. You had to multiply the two functions. That one times that one. So all you do is write them down. 1 over x plus 4 times g of x, root x plus 3 over 1. And the only thing that might be scary here is if you didn't know how to multiply fractions. Multiplying fractions, just multiply across the top. 1 times that makes that. Over x plus 4 times 1 is x plus 4. There it is. Raise your hand if you had that one right. Okay, good. Now, what is its domain? It's made up of the two parent domains. The domain of this one is everything works except -4. Now, on these problems, I would recommend making number lines because you remember how we overlap the two number lines? Yes, you could write it in interval notation at the very end, but at this point, I would make a number line and go -4, and it can't be that. They're really quick to make, and they're very nice and visual. Yes, ma'am?
So for like the homework or whatever, would you like us to eventually write it in?
I would like it like this until the very end. At the very, very end, the final answer should be in interval notation.
So like just the f times g of x should be in interval notation, or?
This part right here, there is no interval notation about it. It's just the answer. There's
like the domain.
the domain of the combined at the very end. That should be an interval notation. Yeah, I don't need this to be an interval notation. I don't need that to be an interval notation. It's only the very, very end of the problem. Okay, so domain of G. Domain of G is everything works here except, well, I got to think this one through. X plus 3 needs to be greater than or equal to 0. X, is greater than or equal to -3. So here's -3. Empty spot. Does it work? Yeah, it does. Bigger than -3 means like that. There we go. Did you guys have the same domain of G as me? All right, good. Then we overlap them. Now I'm going to use the wonders of a smartboard to do that. Grab this part right here, bring it right over here. Make sure that my 3 is not like over here because, you know, then, wait a minute, it's a -3. Anyway, the -3 needs to be right about there. So good. Okay, I have overlapped them. And now where do they actually overlap? I hope you got it was from there over, which makes it from the combined domain of this. Domain of f times g is everything bigger than -3 or equal to -3. So since I wanted that in interval notation, this right here, I would say from -3 to infinity. Does it work at -3? So bracket, parentheses. There we go. There's your two parts to your answer. The actual combined function and then its domain. Raise your hand if you feel like you get this. Good. Now, I'm going to step it up one more notch then. This is the hardest kind. F of x and g of x divided. Now, it's not that hard to actually divide the two things. What's hard is that it adds an extra twist to the domain. Because on the other domains, you just took the two parent ones and overlapped them. On this one, there's an extra twist. And I'll tell it to you once and see how many of you actually remember it. When f of x and g of x were alone, would you agree that it was okay for g of x to be 0 back when it was just a g of x? Functions are allowed to be 0, aren't they? So couldn't g of x be 0? Couldn't it come out to be 0? Yeah, you don't let it, it's not crashing if it equals 0. It's only crashing if there's a 0 on the bottom. But when I put the g of x on the bottom, all of a sudden the g of x that used to be okay to be 0, now it can't be 0. That adds an extra twist to this kind of problem. So only on the divide ones. Whatever's on the bottom, you can't let it be 0. Even though normally functions can equal 0, if it's on the bottom of a combined function, you're not allowing it to be 0. Okay, so now let me show you what that means in terms of a real question. So here's a typical problem. You got f of x is equal to 1 over x plus 2, and you got g of x is equal to square root of x minus 1. Find the domains of both functions. That's the way I would start this every time. Find d of f and find d of g. Make them a number line so that you can eventually overlap them. Then the question would be, find f of x over g of x and its domain. Yes, we have a fraction in another fraction, and you have to be able to handle a fraction in a fraction. That's why it's on my top 20. Top 20 things you got to know for this class. Fraction over a fraction. Pause for a second. We try that one. What did you think the domain of f was? I agree with you. So here's -2. Can't be -2. Can be everything else. Raise your hand if you had the same thing as we did. Okay, good. Now we'll take the back corner. Tell me, I'm not using your name on purpose because it's a video. What can this one be? All right, so you said x minus 1 greater than or equal to 0, and then you said x greater than or equal to 1, so here's a 1, and did I do it right? Okay, good. Raise your hand if you agreed with him on that one. Okay, good. Now, we actually divide the two functions. F of x is this, 1 over x plus 2, divided by g of x, which is the square root of x minus 1. Now that for a lot of people would be a real problem because they don't know how to handle a fraction in a fraction. But you have been taught how to handle this. Do you remember this on the top 20 sheet? How do you handle fraction in a fraction? You flip and multiply. Which one gets flipped? The second one, the 3/4. So it becomes 4/3 like this, right? Now it's a lot easier. You just multiply the tops and the bottoms. Okay, so if you can handle that, then we go over to this one. And we say, wait a minute, there isn't two fractions. So you make them into fractions, because fractions play nice with other fractions. So I'm going to make this into a fraction. And now I'm going to flip and multiply. So I'm going to change it to a multiply by, flip it, 1 over square root of x minus 1. Do you get how I just changed this to a multiply problem? And now the top is just 1. And the bottom, does this need to be in parentheses? Oh, yes, it does. You need to know that anytime you have a fraction that's got multiple parts on the numerator or the denominator, there's imaginary parentheses right there. Be good to put them in. Final answer, 1 over. Do I actually expect you to multiply this out? Nope. X plus 2 times square root of x minus 1. Now that technically doesn't need parentheses around the square root because the square root is a grouping symbol, just like parentheses is. There's my combined function. Now what's its domain? You got to take the one and the other and overlap them. So this, I better move the whole thing at once here. That right there comes over here. And now I make sure I put my 1 right about where the 1 would be on the other graph. There. Now where do they overlap? From there over. So how do I write its domain? The domain of f plus g is equal to from 1 to infinity with a bracket on the 1. Did anybody get that all right? Nice. Okay. Now that was a hard question. Now, wasn't there a third part that I was supposed to include on this? Do you remember me saying this is the tricky kind because we had one more extra thing? Anybody want to clarify this? What cannot equal 0? The g of x cannot equal 0. But wait a minute. When we were solving it, we were letting it equal 0. You remember that? So that meant that x was greater than or equal to 1. What, when you look back on it, would cause g of x to equal 0? If x were to equal what? If x were to equal 1. So do you get how allowing x to equal 1 is a problem? All right. So when we take this domain and we say, okay, you're saying that everything in here works, including the 1 doesn't actually work. Because when we put the 1 in, we'll have a 0 on the bottom. So how should I change this? Just a little bit. A parenthesis on the 1. And that's all it would take for that problem to be completely wrong if you have a bracket there instead of a parenthesis. That's the extra gotcha that you have to watch out for. It's going to happen. Watch out for those. It only happens when you're dividing. It's the only time. You can add them, you can subtract them, you can multiply them, and never worry about that. It's only if you're dividing two functions, then the bottom function can't be allowed to become 0. Yes?
And so you write f plus g even though it was f plus right?
Oh, this should be a divide g. Thank you. F divide g. Sorry, you're right. Whew. All right. This is a problem or a type of problem where it's easy to make little mistakes like that. All it was a notation thing. I actually wouldn't have marked that wrong because it wasn't part of the answer. It was a labeling of the answer. But if I had left this as a bracket, I would have had it wrong. But thankfully, I thought of it before I quit because I needed to change that to a parenthesis because otherwise it was going to actually make my denominator equal 0, and that would be a problem. All right, now let's actually get into your worksheet. We don't have too much time left here. Your worksheet that you're looking for is 1.4.1, and it looks like this. Because I am committed to giving you assignments that are reasonable in size, this is not the way it is. So given the small amount of work time we have, I want you to skip problems 2 and 6 and 11. But the rest of them, do them. This is one of those nights where you will separate yourselves into the kids who really want to do well in this class will complete the whole thing, even though it takes you probably half an hour, maybe even 40 minutes at home. And the kids who are okay with just getting whatever they get probably won't finish. Skipping 2, 6, and 11 are the skips. All right, so number 1 is insultingly easy because its domain is all reals for F, and the domain how about the domain for G? Also all reals. So the domain for the F of X and for G of X, the domain is all reals and all reals. So that's 2 number lines that are completely shaded in, and they overlap everywhere. So the answers for their parent-children functions are all reals, because when you overlap 2 number lines that are always working, then the children don't have any weaknesses either. All right, so let's move on to number. You can handle number 1 at home. That's an easy. Let's go to number 3. A lot of people freak out because it has the word sine in it, but you really know what the domain of sine is. It's not nearly as scary as you think. The domain of sine, unfortunately my smart ink is dyed, so I can't write on this. See if I can figure out a workaround quick today. Okay, so I've got it pasted in on a smart notebook so I can write. The domain for this one is normal. You just say what's underneath the root there, x to be greater than or equal to 0. Okay, so I can do that in my sleep. Here's 0 greater than or equal to 0. That's an easy one. So the domain of F was easy, but the domain of G, I know it seems scary because it's sine. But if you just make a little picture of sine, do you remember what sine looks like? Remember how it goes on and on and on forever and ever and ever? Does sine only start there, or does it go backwards too? It goes backwards too. It goes both directions. So what's the domain of sine? Negative infinity to positive infinity, or you could say all real numbers. You just have to think of what the picture looks like, and it's really not that hard. Domain of sine is all reals. Okay, now I got domain of F and domain of G. That's the way I'd always start these problems. Doesn't sometimes say that, but it's the smartest way to start. Because the only hard thing about it is going to be to combine the 2 domains of the parents. Okay. And now what does it want me to do? It wants me to figure out F plus G. So you go like this. F plus G is, just add them. Square root of x plus sine of x. Do you actually have to do anything complicated to add those together? No. They are unlike terms. You can't add apples and oranges. So we leave them with a plus between them. F minus G. It's not complicated. They are unlike terms. You can't put them together. So there's minus. For multiply, F times G. I just have to go square root of x times sine x. Do I have to actually multiply them? No, they're not like terms. Can't put them together. And then, do we have to do F divided by G on this side of the worksheet? F over G, okay. F over G. Now on square root of x over sine of x. Again, not like terms, so I'm not expected to actually do anything there except say, here's the answer. And now what's the domains? The domain of these first 3 are all the same. Do you remember how this has that extra twist? Because the bottom one can't be allowed to be 0. How would sine x ever be 0? If can x be allowed to be 0? Okay, in case you don't know what sine of 0 is, if you looked at my graph right here, you'd see sine of 0 is 0. So is it okay for a 0 to be on the bottom? No. So since we can't have 0 on the bottom, we can't let x be 0 because sine of 0 is 0, and that would be a problem. So these have just 2 number lines. The 2 parent number lines overlap with each other. This one's from 0 to infinity, and this one's all reals. And so these three answers, this one and this one and this one, are all just the overlap of these two, which is from 0 to infinity. But this one is the one that's got a trick. It's got 3 number lines overlapped from 0 to infinity, and all real numbers. And the third number line is that you can't allow the bottom function, in this case g, cannot be 0. If g cannot be 0, let's look at the g function and say, how could I make this 0? If x was equal to 0, I'd have a problem. So I have put a 0 here, and it can't be 0, but it can be everything else. Where do those all overlap? From 0 to infinity, not counting 0. All right, challenging homework assignment tonight. I hope you rise to the occasion.